Hi, my name is Steve King. I wanted to mention one of the scripts we're going to use today is from Adam Block. It has a series of easy processing things, and we'll be using the easy star reduction. So to get that, let me show you. Here's resources, in PixInsight resources, updates, manage repositories. Okay, and you may have some or you may not have anything in here, depends, but you can add one by clicking on this add. Now I'm going to zoom in on this, and it's this guy right here, the https://darkarchon.internet. Okay, that whole thing needs to be entered, and you enter it by clicking on add, and then you type it in this box, and then you hit OK, and then you can hit OK, and you will have added it to it. If you then go back to resources, updates, I believe if you click on this, check for updates, I believe it will install them. If that doesn't do it, for sure the next time you open PixInsight, it will install those, and you'll find them under scripts, easy processing suite, and the one we'll be using is this easy star reduction. So this is just to let you know how to get those. I'm going to start with, this is going to be an HOO image of the Elephant Trunk Nebula, but the same techniques would apply to SHO. I'm starting, assuming you already have done the linear part, because I don't do anything unique there, any different from anybody else. So I have an HA and an O3 image ready to go, and you pick the one that's got the best signal. For me, that's always been the hydrogen. So I'm going to take the hydrogen, I'm going to make a copy of it, a clone, and I'm going to call it HA Hist for Histogram Transformation, HA Hist. Okay. And now I'm going to stretch it. Nothing unusual here, just normal stretch. Let's select the view here, HA Hist. An unusual histogram has two peaks. Doesn't really make any difference, but is a bit unusual. I'll lower the background a little bit. Let's see what the background is going to be here. This is around 0.1, 0.12. Let's drop it down just a little bit. So 07, 08, 0.1, somewhere in that range. Okay. Looks reasonable enough. We'll go with that. So that's our HA image. Keep that here. We'll do the same for the O3. Make a clone. This one I will just call O3 temp, because we're going to be changing this one. temporary. And when I stretch this guy, first let me get rid of the screen transfer. Okay, 03 temp. I'm going to size this back down to size of the HA because we're going to be comparing these two. And now we stretch again. Okay. And stretch, you can see this one is clearly much weaker signal. It takes a lot more stretching to bring out any of the nebulosity. Now what I want to match here, I want to match this area over here, which has no nebulosity in either one. So I want to match the background and I want to match the stars so they look similar. So let's get the stars up where they're looking kind of the same. And I'm going to have to do some more adjusting here. Need to clearly lower, change the black point here with the left slider. 0.91, so it needs to come down just a little bit. The other one's like 07, 08. So that looks pretty similar. And the stars, well, they're comparable. Maybe a little bit brighter over here, but not bad. So it's about a match. So I'm going to close the preview, apply the stretch to it. So we now have the background in the 03 here about matches the background level in the HA here. And the stars are looking similar. Don't worry about the bright one. They're greatly different in the two images, so no need to compare them. But clearly the nebulosity in the 03 is way too low. So what we do is we open a, oops, not that guy. Open a range selection process. Make sure the 03 is highlighted. And we want to find a range mask that will basically include the nebulosity of the 03. You may notice I've set the smoothness to 60. So that'll make it somewhat blurred, rather blurred, so we'll have a smooth transition on the range mask. Okay, so let's take a look here. That's actually not bad. Change this to 13. Seems to capture most of the nebulosity. So we will drag the triangle onto it, create a range mask. Okay, close the process. But this bright spot here has nothing to do with the nebula. That's because of this bright star. So we'll open the clone stamp tool and just eliminate that spot there. And execute. Okay. Now we can take this range mask. By the way, if you were doing SHO, you'd want to maybe further identify the range mask. So double click on the name there. And like this one is the 03 range mask. We only have one, so it wouldn't be confusion, but just so you can see. Now we'll apply that mask to the 03 temp image. Go up to mask. Oops, gotta highlight this guy. Mask. Show mask, turn it off. Now we can open up the Histogram Transformation tool. Looking at 03 temp still. Put on the preview. And now with just the middle slider, slide it over to the left. And we want to bring it up until the nebulosity in the 03 image is comparable to that in the hydrogen side. So here they're comparable. Not exactly the same, but different gases. So close the preview and apply. Mask. Remove mask. Okay. So now we have the HA and the O3. However, there is a problem. Because we boosted the nebulosity, we also boosted these stars. So they're going to be bloated. And when they get combined with the HA stars, which are tighter, we're going to have very fuzzy stars. But we can fix that. And we'll fix it by making a couple copies of this image. So let me show you what we're going to do. Let's close the HA, put him over here. The O3, we're going to make two copies of. One we're going to call ORIG for original, same as the O3 temp. And I make another copy, and this one's going to be capital EZ. Okay. We're going to open up the script EZ star reduction and apply it to the EZ image to reduce the stars. Okay, I'm going to open the EZ star reduction process. We select the view. That's the EZ file we're looking at. We want to create a star mask. I'm going to pause this while it does the job. Okay, it finished creating the mask. The mask is located somewhere here, don't know where. Anyway, it's there, you don't have to find it. So now it's ready to run the star reduction, and this doesn't take long at all. You just click on this button, and there it is. There's the finished products. It's reduced stars across the whole image. Here's the file that it created. We don't need it anymore, so we can delete it. Hit yes twice and it's gone. Open Pixel Math now, and in the RGBK file, you put in the expression as shown here, $T times EZ plus, in parentheses, 1 minus $T times ORIG. And what this is going to do, it's going to combine these two images. But when we run this process, we drop this blue icon on the range mask. And that's this is the $T image. So it's going to multiply that times EZ. So it's only going to pick out the stars that are where the bright part are. And then 1 minus $T, which will be the black parts, will be the original image. So if we just drop this on here, get all these guys down. O3 temp, put him here. This guy is now going to be renamed O3 underline HIST. So it's the O3 image. It's had the nebulosity boosted, but the stars inside this nebulosity, although they were bloated when it was boosted, they've been reduced back down with the easy star reduction script. So we'll get better stars overall. So we have our two things. We no longer need this. We no longer need this. And we don't need this, but I'm going to save this mask just in case I wanted it sometime later. We're now ready to combine the HA and O3 images. And I have a little pixel math that I use for that. The red channel is going to be the HA hist. The green channel is going to be a combination of the O3 and the HA data. And this letter F represents the fraction of O3 that we're going to use. So that fraction, that F, is defined over in symbols. You just type in F equals, in this case I'm going to use 0.7. So we'll have 70% of the O3 and 1 minus 0.7 or 30% of the HA will be the green, and the blue will be all oxygen. We're going to create a new image down here. I'm going to call it HOO, and just click the brown button, and there you go. We have the HOO image. And we can take a look. How do the stars look? Not too bad, considering we boosted the patooties out of it. If you get outside, the stars are even a little sharper, but even inside, they're not too bad. The big ones are a little bit soft, but we'll see if we can't sharpen them up a little bit as we go along. We can add a little color saturation to it. Click on the S for saturation. Open the window. We can put this preview back at full size here. Make it bigger anyway. We can just boost this up a little bit to give it a little more color. Okay, now at this point we can take a look. How's the image looking here? It's got a bit of noise in it. Let's just create a window here. Preview. Open the preview, open it up. Let's open up the TGV denoise. This is a mild setting of noise reduction. Let's see what this does. Oops, actually I should, before I do this, go back to HO image. Let me just get a luminance image. Apply this as a mask. Put my masks over here. Mask, invert mask. Okay, so let's not show it anymore. Now let's go back to preview 1 and let's put this on here and see what it looks like. I have this little arrow to undo preview, toggle back and forth. So this is before TGVD noise, afterwards. So it helps a little bit. Maybe we can do a little bit more. Let's change this -4 to -3 and change this to 2. Let's give that a try, see what that does. Oh, that's quite a bit nicer. So this is before, this is after. Definitely looks nicer. What is that doing to our elephant trunk here? Let's open this up a little bit and see what this looks like. Well, softens a little bit, not bad. Doesn't seem to really destroy anything. Let's move this preview up here and take a look at this guy. Yeah, that looks just fine to me. Preview, delete all. So I'm going to apply this to the image. And this will take a little bit, so I'm going to pause this. Okay, the noise reduction is completed. Let's see, it has not had too large an effect on the sharpness, and we'll take care of that later anyway, but it has definitely cleaned up the noise. Here's the noisy, here's after TGV. Okay, we can remove the mask. So we now have our image. Now we want to sharpen it. So the way we can do that is with the LRGB process. One of my favorite processes. First thing we need to do is open our HA image. I'm going to use this for the sharpening. We'll make a clone of this. So this is the histogram HA, the hydrogen data. Sorry. And I'm going to call this HA hist sharp because I'm going to sharpen it. Okay. before we sharpen it, let's take a look and see if it's noisy. Because if this is noisy, the final image will be noisy. So it's not really too bad. Normally I would probably make a copy of this, apply it as a mask, invert the mask. So we see it protects the brighter areas. And then do TGV denoise on this to get rid of any noise. But for purposes, well, I guess I can do it because I can just pause. Since this is fairly noise-free, I will use just the lower setting that I start with on this. So we'll do a denoise on this one also. So I'm going to pause again while it does this. Okay, this one didn't take as long because it's only one channel. I'll close that. So you really see very little difference. So it's a little bit cleaner. Remove the mask. Okay, now I use the multi-scale linear transform with the settings shown in the box here. And I apply that to this, and this provides sharpening. Okay, close that. By the way, if you wanted more sharpening, you just increase the size of these numbers here. But I don't like to overdo it, but it's up to you how much you want. The next one, I use the local histogram equalization process, set the kernel radius to 26 and the amount to 0.15, so I'm only using 15% of it. So it's a mild amount of enhancement, and 26 means that's a fairly small number for kernel, means it'll enhance objects that are somewhere around the order of the size of 26 pixels. Not exactly, but kind of like that. This process runs fairly fast also. There you go. And then I do it one more time, but this time everything's the same except the kernel is now increased to 110, so it looks at larger area, enhances larger structures. Okay, so we've sharpened it and we've enhanced contrast. And this now we're going to use as the luminance. Set this guy right here. Close this. This we can get rid of. This was used just during the noise reduction. Now I open the LRGB combination process. Only the L channel is checked, not R, G, or B. I run the lightness and saturation both at 0.5. I do not check the chrominance noise reduction. It can wipe out some low-level color nebulosity, and I don't like that. We click on the right here, open the chain, and we look for HA Hist Sharp. This is one we just sharpened. Now, before we drag this over, let's take our HOO image, make a clone, double click on the name, and change that to HOO LRGB. So this is the one we're going to apply the process to. But before we do, since the sharpened image that we're going to use for luminance is what gives the sharpness, you can do a little trick here. If we look at this guy, noise is actually very low in this one, which is a very good thing. So really, I'm not sure we need to do anything, but what you can do, I will show you, and oftentimes you may need to do this. Let's make a preview here. Go to the preview. We can go to the convolution tool. Convolution, aspect ratio 1, shape 2, standard deviation. This is the one that you adjust. And let's do a preview. If you have noise in your image, oops, wrong slider. If you have noise in your image, you can just slowly increase the convolution to blur it till the noise disappears. So maybe we'll do a little bit here, and it'll smooth out the image. This value is normally, where I have 1.5, normally in the 2 to 4 range. The noise on this one is so low that we don't even need 2. So we go back to the full image, turn off the preview, and apply a gentle blur to the image. It seems funny, we want the image to be sharper, but we're blurring it. But that's for reasons that in the final image, it'll help reduce the noise. And now, to this image, we take the LRGB combination, blue triangle, and just drag it onto here. And in one moment, we have an image that is considerably sharper than what we had before. The stars are sharper. The details are sharper. Notice the detail in the elephant and in the swirl down below it. Now at this point, what I do with the process depends on how the overall processing is gone. First thing I might do at this point is open up the Histogram Transformation tool and look at HOO LRGB. We can see that the blue, green, and red down at the bottom here are all right together. So that means that the black areas will indeed be pretty black. That's the first thing I would check. If not, then I would move the left slider for the red, green, or blue, whichever one was not in the proper position, to move it over into alignment. That'll make your black areas black. Second thing I would do is probably increase the color saturation a little bit at this point. I generally do too much of this, so you don't have to follow my guide. I just like colorful pictures. The third thing that I often do is a little bit of an S-curve. So where are these guys? Down in here. So we'll take this area down just a little bit. Raise this one up just a little bit. Yeah, I like that actually. I like the way it makes it pop a little bit. This is getting into personal taste now, but the techniques I've shown you. But another thing that is useful to know, if you go to Scripts, Utilities, Color Mask. First we will look at this bottom thing, blur layers. This makes sure that any color adjustments you do are blended at the edges, blurred out. And let's look at blue and just click OK. Okay. Drag this over as a mask on HOO LRGB. Mask, show mask to make it go away. Now open up our curves transformation. You can try just increasing the saturation, see what that does. It brings it out actually rather nicely. That's a nice soft touch to the blue. Puts a blue halo on some of the stars too. I don't like that. Let's see what happens if we look at just blue. Looks kind of nice also. Well, maybe I'll go with that. You can run the SCNR tool. In case there's any green in here, it will get rid of it. And then go back to Utilities, Color Mask. 1, 2, 3, and yellow. Okay. Now, before I go anywhere on this color mask, I do not want to enhance this yellow around this star, which is showing up right here. So, I'm going to get the clone stamp tool, make it smaller, don't know what size it needs to be. Let's see here. Well, it could be probably about okay. So it won't enhance that. Now I'll apply that here. See, I may have to soften that edge a little. We'll see. Open up the curves transformation. Oops. Let's highlight the file first and then, there we go. Now let's look at saturation. So maybe that's the effect you're looking for, or you can tone it down. Depends on where you like it. Here are a couple more things that you get the idea. I already ran the Easy Star star reduction. So take a look. So here's what we finished with. Here's after star reduction. If you want to make the nebula stand out a little more. And another thing you can do, you can combine this, the LRGB image, with the HOO image. Let's go to Pixel Math. Okay, go expression editor. Go to symbols. Click in here and type F equals and try 0.7. Go to RGBK and do F times HOO LRGB plus 1 minus F in parentheses times HOO. So we're taking a fraction of the LRGB image and adding it to 1 minus that fraction of the HOO image. So we can blend them. In this case, we're going to take 70% of the LRGB image and add it to 30% of the HOO. Okay, we're going to create a new image. We're going to call it blend because we're going to blend them together. Then all you do is push the square apply button. Okay, tuck this down out of the way. So here's the LRGB. Might be a little too crunchy for some people. Here's the LRGB. And here's the blended image to tone it down a little bit. Maybe that's a little more to your liking, but you can change the blending any way you want. So I just thought I'd show you one other little nice trick for blending images. Okay, there you go. So thanks for watching. Hope it helped you in some way.